Yes, hello. Well, we made a lot of progress in the last video. We got to a stage where we'd done the basic refactoring to some degree. We cleaned up the code a fair bit, and we're now ready to think about what we need to do in order to make the code, in order to make the change easy, in order to add a back button. If you recall, we have this game file namespace which modifies a game state, which models a game state, in that you can imagine people playing on a table and then having this game state running on a computer and then telling it, okay, this player has done that, this player has done this, what is the current state, just so we don't have to remember how many points someone has or whose turn it is. The game state, that's what this game namespace is about. And of course, if it was done in a sensible way, you would actually have lists of questions to ask, so we could just ask the game what's the question, then we can answer, and then we can just press the button, oh, this player answered correctly, this player answered incorrectly. And the question is, what happens if we press the wrong button and we want to go back to the previous state? We want to take that answer back and say, no, the person did actually answer correctly and not incorrectly. At the moment, that would be very difficult to do, because our state is being modified constantly. We have this one state atom, and we have lots of functions which just modify it. That's what this swap does. It just modifies the contents of this state atom, and then after that's happened, this state atom is gone. The old value of the contents of the state atom has gone and no longer exists. So going backwards is tricky. So the easiest way to solve the problem is not to have one state atom, but to have a state stack. And then if you want to go back, you just say, okay, well, let's go back to the previous state then. And every function which at the moment modifies a state will instead produce a new state, which you can just add to the stack. That's the basic idea. If you want to make your code immutable, which is what we're going to be doing here, we're going to try to increase the immutability of our code. So the mutable stuff happens at one place or two places, very high level, right? Or the first functions which are being called, basic function. Maybe in the basic loop we're going to be performing mutation, otherwise nowhere. The rest of the code will be immutable, and then in this basic loop we will just be able to call, let's say, at some point we will be calling roll, and the roll will take a state in the roll and it will return the new state, and then we will say where we are calling that roll function, that's where we're going to save the new state to the stack. That's the basic idea. So we have lots of places where we are painfully aware that state is an atom which we are mutating. Some of the places are quite trivial to modify. For example, here at get current player state, we could just give this the current state structure as a parameter, and then we wouldn't need to mention this. We wouldn't need to use the fact that state is a global atom in the function. So the idea would be to replace this with a state, and now every time where it's called get current player, we would like to add to it as a parameter the state. So let's do this quite quickly. Let's just replace this in the current buffer like that. See if I broke something. It may still be okay. Yes, it is. So by doing this, we've taken the fact that state is an atom, we've removed that from this one leaf function. So this function's become immutable is not the right word, but it's become a pure function in that it takes all the information it needs in order to work. It gets from outside. There's no magic global variable which just has to be set a certain way. It takes everything it needs from outside in its parameters. What's the next place where we can do this? Is there another function which is this easy? Yes, player 1 is this easy, isn't it? Player 1 could take a state. How many times is this called? Once. Okay, well, this is a very easy one to do. Let's just give it the state here. Let's just say it takes a state as a parameter, and we're going to give it state here. Let's see if this worked. Yes, it did. What's the next one we can do? The next one's going to be more difficult, I think. All the other ones, like for example, pay player, that modifies the state. That will have to modify the state. It will have to return a new state. We can do it. We just have to take this swap part up to the places where pay player is called. Where is it called? Well, it's only called once, so this isn't particularly difficult to do. So we're going to update the state here, and we're going to swap it where it's being called. So swap state pay player. Oops. Let's see if I got that right. Did I break something? That's okay. What's the next one we can do? So this is all now pure functions here. Let's take these up to the top so we don't worry about them. They're all pure functions, so who cares? Oh, here's one. How many players? That's a reference to a global variable. How often is this used? In 2 places. It's not the most interesting function, but let's make this as well a pure function. So as I said before, we're taking the atom further up the call chain, and instead we are calling pure functions. That's the idea. Ask question is a more complicated one that's doing a fair amount of work. Advanced player is doing a fair amount of work. Which one do you want to do first then? How often is advanced player being used? Oh, it's just being used once. Well, perfect. Let's do this one then. This is going to take a state and a role, and it's going to update in state the position of the player. Good. And then where it's used here, we swap the state with advanced player role. Let's see if I got this correct. Did I break something? Oh, get current player is not correct. I haven't yet defined it, have I? Well, I can't do that there then, can I? It's got to be after the definition of get current player. Good. Let's see if this works now. Yep. Clojure, every function you run in Clojure, it has to, or you can't call a function which hasn't already been defined. Clojure passes the code from top to bottom. Other languages don't do this. They pass the whole file and then say, okay, these are the functions which exist in the file, and let's see if that still works. Clojure doesn't. Okay, well, how are we doing now with state? The next one will be next player, I think. This is used a few times. Next player I'm looking for. Yes, there we are. Let's move it closer to where it's used. Here we are. Put it in here so we can see everything on one page. Here, those are all the uses. So we know how the game works. We take a state, and then we update in the state that, and we return the new state. And next player will now be a swap state next player. And the same here. Is this still okay, or did I break something? This looks okay, good. Where else? So we've got state. So we've got state in the, we've got the fact that state is an atom, we've got it in wrong answer, we've got it in was correctly answered. We've got it in role. Is there any other place we know that state is an atom? Oh, in turn we know that state is an atom. Let's see, in any of the leaves of turn as well, we have here ask question. That knows that state is an atom, I think. Current category does not, but ask question most certainly does. Okay, so ask question also modifies state. How often is that used? Once, perfect. Well, let's give it a state and return a fresh state from it. Then we can call swap in swap ask question. Okay, let's see if this works. Did I break something? It works, great. So the next thing to do, I think is the only function which isn't top level, which knows that state is an atom, or which deals with the state atom, is turn. So the idea would be to make this take a state. This looks like a more difficult one to do. Let's make a copy of it and see what we need to change. Good. Let's call the copy turn s. Take state. The first bit's easy. We just dereference it. Ooh, now we've got a problem. At this point we are swapping the state already, and we don't want to do that. Let's create a new state here. Is advanced player state role. Okay, good. So now we have the new state. This line goes away. Now we can use the new state. Actually, just one more let clause, isn't it? So let's get rid of the additional let clause. There we are. Print line, that's okay. Print line, that's okay. And then we're doing another swap. But we can just ask question here. Okay. And we've got one bracket too many at the end. Let's see if it's syntactically okay. Seems to be. Now let's try to use it. Where's turn used? It's used twice. So swap state turn s role. Swap state turn s role. Okay, let's see if this, what do I do then? Turn S, save it. Let's see if this still works. Did I break something? It works. Good. I think this means that we are only using the state atom in 3 or 4 places now. We're using it in the add function here. Is playable is not used, I think. No, it's not. Let's just delete it. It's not being used. So the add function uses the state atom. Who else uses the state atom? I think it's just the top level functions now. Role uses the state atom. Was correctly answered uses the state atom. And wrong answer uses the state atom. Okay, well, we've made some progress now. Let's leave this video where it is, and we'll have a look at the top level functions in the next video.